Electric charge. Electric charge. Electromagnetism. The sciences of electricity and magnetism developed separately for centuries until 1820. In fact, when Hans Christian Ørsted found a connection between them. An electric current in a wire can deflect a magnetic compass needle. He is from Denmark. The new science of electromagnetism, the combination of electrical and magnetic phenomena, was developed further by works in many countries. One of the best was Michael Faraday. That talent is attested by the fact that his collected laboratory notebooks do not contain a single equation. He's from the UK. In the mid-19th century, James Clerk Maxwell put Faraday's idea into mathematical form, introduced many new ideas of his own, and put electromagnetism on a sound theoretical basis. He's from UK too. Electric charge. Electric charge is an intrinsic characteristic of the fundamental particles. That is, it is characteristic that automatically accompanies those particles wherever they exist. The positive and the negative labels in science for electric charge was chosen arbitrarily by Benjamin Franklin. He is a great physicist and a politician in USA, the founder of University of Pennsylvania, Philadelphia, and USA. Charges with the same electrical sign repel each other, and charges with opposite electrical signs attract each other. You see, this is a glass hand over, can rotate. If you had positive charge on it, and we take another glass rod with positive charge, close it, and we find they repel with each other, and the straw rotate this way, okay? If we use the opposite charge on the plastic, close it, and we find they will attract with each other, and the rod rotated in this direction.
These pairs of ping pong balls coated with conductive paint will be used to show electrostatic attraction and repulsion. This pair of balls hang on wires from a metal support, so they are electrically connected. If we touch a negatively charged rod to the metal, both balls acquire negative charge and separate because of the repulsive forces between them. This pair of balls is electrically insulated from each other. We'll touch one with a positively charged rod and the other with a negatively charged rod. The balls acquire opposite charges and attract each other until they touch and neutralize their charges.
This Wimshurst machine is used to produce very high voltages. One side of the generator becomes positive, the other negative, until the voltage between the electrodes is great enough to ionize the air between them. We'll use the Wimshurst to put opposite charges on a pair of metal plates. A small pith ball tethered by a thread shows the attractive force between the opposing charges. It picks up a small amount of charge from the bottom plate and is lifted toward the top plate by an electrostatic force. If we drop a conductive ball through this tube and into the space between the plates, the ball bounces energetically between the two plates, transferring charge between them. When the Wimshurst machine stops, the plates are rapidly neutralized by the bouncing ball. When the charge is mostly gone, the ball stops.
Here's a device called an electrophorus, which generates electric charge in an interesting way. It consists of an acrylic sheet and a round metal plate attached to an insulating arm. If we rub the acrylic with a wool cloth, the acrylic acquires a positive charge. The metal plate is then placed on the acrylic. A grounded wire is then touched to the metal plate. If the plate is now lifted off the acrylic and brought up to a second metal plate that is grounded, a spark jumps between the plates. If we repeat the procedure without recharging the acrylic sheet, we can get another spark. And another. How can we continuously generate charge without recharging the acrylic? The electrophorus works by electrostatic induction. When the neutral metal plate is lowered onto the positively charged acrylic, the negative charges in the metal are pulled to the bottom of the plate. That leaves a net positive charge on the top surface of the plate. When the top surface is connected to ground, electrons conducted from the ground neutralize the upper surface. The plate now has a net negative charge. The positive charge is still on the acrylic, so the cycle can be repeated. This device contains a small piezoelectric crystal, which can be squeezed by pressing down on this lever arm. When the arm is pressed, the high voltage generated in the crystal causes a spark to jump between these two electrodes. When the crystal is released, another spark jumps. This animation shows the voltage being generated by the crystal. When the crystal is released, an opposite voltage is produced.
The term electrostatic is used to emphasize that relative to each other, the charges are either stationary or moving only very slowly. The application for electrostatic can be pen spraying, powder coating, flat edge precipitating, non-impact inkjet, printing, photocopy, and decide boy and girl. When woman pregnant, it is boy or girl decided by the charge she carried.
Electrostatic precipitators are often used to remove pollutants from industrial smoke before it reaches the atmosphere. To demonstrate the effect, we'll use this acrylic tube with a metal conductor at each end, connected to an electrostatic generator. Smoke is put into the chamber with each of the conductors hooked up to one end of the generator. The high voltage that is generated sweeps the smoke particles out of the tube.
We'll use this model house and a high voltage electrostatic generator to demonstrate how a lightning rod works. One side of the generator is connected to a metal ball inside the chimney. This sharp rod is also electrically connected to the same side of the generator. The other end of the generator is hooked to this copper sphere, which simulates a charged cloud in the atmosphere. When the generator is cranked with the lightning rod down, large bolts strike the chimney. When the lightning rod is raised, the bolts stop. When the lightning rod is lowered, the large bolts resume.
Conductors and insulators. In some materials, such as metals, tap water, and the human body, some of the negative charge can move rather freely. We call such materials conductors. This is a neutral copper. If we move a charged plastic closer, you see, because the negative charge can move, so it's repaired to the far end, and the positive charge stay there for attracted. In other materials, such as glass, chemical pure water, and plastic, none of the charge can move freely. We call these materials non-conductors or insulators. Semiconductors, such as silicon and germanium, are materials that are intermediate between conductors and insulators. The microelectronics revolution that has transformed our lives in so many ways is due to devices constructed of semiconducting materials. Finally, they are superconductors, so-called because they present no resistance to the movement of electric charge through them.
This electroscope can detect the presence of electric charge. When a charged rod touches the top of the electroscope, the pointer deflects. We'll use the electroscope to compare the way charges move in different materials. A rod with two arms is plugged into the top of the electroscope. The right arm is an aluminum rod, while the left arm is acrylic. When we touch a charged rod to the aluminum arm, the electroscope deflects, showing that charge has moved through the aluminum arm. Aluminum is an electrical conductor. If we touch a charged rod to the acrylic arm, there is no deflection. Acrylic is an insulator and does not conduct electric charge. An electroscope and a pair of metal spheres will be used to demonstrate electrostatic induction. If one of the spheres is charged, the sphere can cause the electroscope to deflect. Now we'll start with both spheres neutral. The spheres are placed in contact with one another. The negatively charged rod is brought near, but not touching one of the spheres. The spheres are separated, and the rod is removed. When one of the spheres is touched to the electroscope, the scope deflects. What will happen if we touch the other sphere to the electroscope as well? The electroscope goes back to zero. The charges induced on the two spheres are equal and opposite. This animation shows how the charges develop on the two spheres as the charged rod is brought near. Electrostatic generators, such as this Wimshurst machine, use electrostatic induction to separate positive and negative charges and can create very high voltages. Here's an animation of a very simple type of electrostatic generator known as a voltage doubler. An acrylic disc with small pieces of metal foil near its outer edge is mounted so that it can rotate when turned by a crank. Two metal shells are wrapped around the edges of the disc. A metal bar with conductive brushes at either end contacts two of the foil pieces at the positions shown. Assume the two metal shells start out with a small imbalance of charge, so that one is more positive than the other. That charge imbalance induces charges on the two foil pieces, which are in contact with the brushes. When the disc rotates, these foil pieces break contact with the brushes, each coming away with a small charge that is opposite that of the metal shell on that side. Each foil piece that follows comes away with the same charge. When these charged foil pieces reach the center of the opposite shell, they contact a conductive brush inside the shell and surrender their charges to that shell. As charge builds up on the shells, the process of induction becomes stronger, leaving more charge on each of the foil pieces and accelerating the charging process. If discharge rods are attached to the shells, a spark will pass between them, reducing their charges and starting the cycle again. Here's an interesting device known as a Kelvin water dropper that generates static electricity from the energy in falling drops of water. Water is allowed to fall from these two droppers through metal rings and into the metal cans below. After a few seconds, enough voltage develops between the cans to flash a small neon bulb. This animation shows how the generator works. Assume a small charge imbalance initially exists between the cans. The can which is more positive is connected to this ring, and the positive charge on the ring attracts negative charges into the droplet at the end of the dropper. The droplet breaks away, carrying the negative charge down into the negatively charged can below and increasing the charge on the can. On the other side, positively charged droplets fall into the positively charged can. The charges on the two cans increase until the voltage is high enough to flash the neon lamp.